225. So we're talking about higher index radicals today, and before we kind of get to that, we're just going over making a chart of our perfect squares, which we already have. These we're familiar with, 1 through 15. We're a little bit less familiar with perfect cubes, but we have done some work with them before. We've done the factoring sum and difference of two cubes, so we've looked at a couple. So perfect cubes. 1 is also a perfect cube because 1 cubed is still 1. So 1 is a perfect square and a perfect cube. What do I get when I cube the number 2? 8. So 8 is my next perfect cube. What's the next one? 27. And you get that from 3 cubed. And then what is your next one? 64. Jeez. The next one, 125. We're going to go up to 10 on this one. Anybody know 6 cubed? No. Sure. 216. 7. You might know this one. It's 343. 343. 8 cubed. Anybody know 8 cubed? It's 512. 9. You don't need to, but it'll save you time if you recognize them. 729. And then, of course, everybody knows 10 cubed is 1,000. Okay, so there's your cubes 1 through 10. And you notice, obviously, they get really big really quick because now I'm cubing the numbers instead of squaring. So, how do you think perfect fourths are going to work out? We're going to find out. We're going to go all the way to fifths. Squares, cubes. I don't know if this has a name, like squares, cubes. We just say fourths, but if there is another name, I don't know it. So, 1 is still a perfect fourth because 1 to the fourth. But now, what about when you raise 2 to the fourth power, what do you actually get? 16. 3 to the fourth. 81. 4 to the fourth.
What's 16 times?
256. And we'll only go up to 5. 5 to the fourth would get you. Remember, it's really 25 times 25. 625. So, jump ahead though, you would know 10 to the fourth would be 10,000. So, do you need to memorize these? No, of course not. But like I said, if you start recognizing these numbers, you're going to save yourself a lot of time later on. So, even when you're taking the final exam, when it says something like, I don't know, factor x cubed plus 216. If you realize, oh, 216 is a perfect cube, that's going to remind you, oh yeah, I just do sum or difference of 2 cubes. But anyway, let's do our fifths. So again, we start off with 1 because 1 to the fifth is just 1. 32, yes. That comes up, 2 to the fifth comes up all the time. So make sure that you know that 2 to the fifth is 32. You should know all your powers of 2. How about 3 to the 5th? Yes. At least I'm pretty sure. Yeah. We'll just go up to 5 on this one too. 4 to the 5th. 1024 and 5 to the 5th. 3125. And of course 10 to the 5th would just be 100,000, right? So all your powers of 10 are easy because it would just be a 1 with that many zeros on it. All right, great. So if you have this chart in front of you, simplifying radicals that aren't square roots will be a little bit easier. So let's go back and talk about some things that maybe you don't even know. I don't know. Maybe you know this, maybe you don't. Did you know that when I ask you to take the square root of, oh, I don't know, 36, for example, did you know that there's a little teeny tiny number right there? It's not a 1, it's a 2. So when we take a square root, there's really a teeny tiny 2 right there that we never even write. Yeah, so here's how they kind of work out. There's a number that goes right here, and that number is called the index. That's its vocab word. You may have never heard of this before, because usually you only deal with square roots, and when it's a 2, we don't write it. So you may not even know that there can be a little number that goes there. Or maybe you do know, I don't know. So if I want to take some other root besides a square root, I have to tell you what root I want you to take, and that's how I do it. I change the index. So if I want you to take the cube root of 8, for example, I write it like that. So the index has now changed. This is a cube root instead of a square root. If you ever see a 2 there, it's the same thing as a square root. It's just the same thing as writing like x or writing x to the first power. Do you need that little 1 there? No. Same thing with a square root. You don't need to write that little 2. Can you? I guess, but nobody ever does. Okay? So, but if I need to take a cube root or a 4th root or a 5th root or any other root, I'm going to need to tell you, and that's how I do it. Okay? One thing that I want to make sure, and I'm going to make a big deal about this because it's going to, I mean, I don't want it to mess you up further down the line. You have to be careful how you write that index. I like to think of it as a bird on a perch. So this is its little perch, and it's just like a little bird right above the perch. The reason why I'm saying this is because we get sloppy. I get very sloppy too. Because if you write this fast and it kind of looks like that, that kind of looks like 3 times the square root of 8 and not the cube root of 8, right? And they're totally different. So you have to be really, really careful. So just make sure that your index is small. It's up in there in that thing. So some of you are weird with your square roots. You do like this or something, but that's not a square root. Square root is like that. So you should have a little tail here or a perch for your bird to sit on. Okay, so if you need to write a cube root or a 4th root or a 5th root, whatever, it's got to be a small index tucked up in that tail. Bird on a perch. Yeah? All right. Any bird watchers in here? You do? So I have bird feeders, and we put up a hummingbird feeder. I've been waiting. I'm like, oh, is a hummingbird going to come? I got a bunch of hummingbirds. Well, I don't know if it was the same one that just kept coming back. But I'd like to take pictures of them at the bird feeder.
Do you have any?
Yeah.
Can you see them?
They're on my camera at home. But if I remember.
Alright.
I can show you some of the ones that I've posted on Facebook from years past. I can show you. But the hummingbird ones are from. No! We're in the middle of roots. It's very important. So, any Hoosers. All right, so now that I've explained that to you, we can change the index by changing the bird on the perch. Make sure it doesn't look like a big number out in front. All right, now let's talk about simplifying these. So let's recall. If I ask you to simplify the square root of 50, for example, 50 is not a perfect square. If you look in your list of perfect squares, I do not see a 50 anywhere, do I? No, I don't. So what did you do to simplify this? Right, you would figure out, well, what perfect square does go into 50? And I want the biggest one. And the biggest one that divides evenly into 50 is 25. So I'd split this up into the square root of 25 times the square root of 2. And I just get out 5 root 2. Remember that? Old news? Easy peasy? We've been doing this for forever, right? All right, well now we're going to try it with cube roots. Say I wanted you to take the cube root of, we'll start off with, how about 250? So 250 is not a perfect cube. I'm looking in that list. I don't see a 250. So I want the largest perfect cube that divides evenly into 250. So if you're looking at, make sure you're in the list of perfect cubes now. Look in this list for the largest number that would divide evenly into 250. Those are not perfect cubes. The perfect cubes are 1, 8, 27, 64, 125, 216, 343, 512, 529, 1000. 125 does go in, doesn't it? Hooray! So I'm going to split this up just like I did with a square root, but you have to be careful. These are cube roots. So it splits into the cube root of 125. See, you have to put the 3, because if it's anything other than a square root, you have to have it, times the cube root of 2, right? Because 125 times 2 gets me back to that 250. But now I know the cube root of 125. It's just 5. So this simplifies to be 5 times the cube root of 2. And there's my answer. Good morning, Miss Savia. Sure. No problem. Bye. Yes. I'll give you the sheet. I don't know what we're going to do from today. Yeah, so look on Google Classroom for what we end up working on. All right, so there's that cube root simplified. Okay, try another one. How about the cube root of 40? Almost. You said 2 cube root 4?
No, it should be.
Okay, so I look at my perfect cubes. 40 is not in that list. I look for the largest number that divides evenly into 40, and it's 8. So this splits up into the cube root of 8 times the cube root of 5, and then the cube root of 8 is just 2. And then the cube root of 5 just stays as it is. How's that? Is that all right? Here's something that might be unusual. What if I asked you to take the cube root of negative 3,000? Are you going to have to deal with I, do you suppose? Whenever we took square roots of negatives, we had to deal with I, right? Do I have to still? The answer's no. Why not?
But if you cube a negative, it's always going to be positive. Well, because like negative 2 times negative 2 times negative 2 is negative 8.
Which is why I don't need to use I. Because I can take the cube root of a negative number. For that exact reason. The cube root of negative 8 is what? Negative 2. Because, exactly what he said, negative 2 times negative 2 times negative 2 is negative 8. So now, when I try and take the cube root of a negative number, I don't have to worry about i's. I'm allowed to take cube roots of negatives. I can do it all day long. So I'm trying to take the cube root of negative 3,000. So obviously 1,000 jumps out at you, right? I hope. So what I'm going to do is I'm actually going to split this up like this. I'm going to put the negative with my perfect cube. So I'd split this up into the cube root of negative 1,000 times the cube root of 3. Right? Negative 1,000 times 3 is still 3,000. But I can take the cube root of negative 1,000. It just comes out to be what? Well, what's the cube root of positive 1,000? $10. So the cube root of negative 1,000 is just negative 10. That's all. So this answer is just negative 10 cube root of 3. And that's it. So taking cube roots of negatives, not a big deal. It just comes out negative. Ready to try some fourths? Oh gosh. I think you are.
We have to use
Huh?
we have to use I for 4.
You would have to use I for taking the fourth root of a negative number. Absolutely. I probably won't make you do that. Maybe. All right, so let's try something like, oh, I don't know, the fourth root of 162. So if I ask you to do this, you look in your perfect fourths column, right? And I'm looking for 162 in this column. It's not there, so it's not a perfect fourth. So then I look for the largest number that would divide evenly into 162. And it just so happens to be, what did you say? Right, 81. 81 will go in twice, right? So I break this up into the fourth root of 81 times the fourth root of 2. I'm sorry. But now I know the fourth root of 81. What is it? 3. So it's just 3 times the fourth root of 2. That's it. So the process is the same. You just got to make sure you're using either a perfect cube, a perfect fourth, or a perfect fifth, depending on what index you're doing. You with me? All right. So try this one. How about simplify for me the fourth root of 48. Okay, we got an answer? What is the largest perfect fourth that divides into 48? 16, thank you. So I get the fourth root of 16 times the fourth root of 3. But now I know the fourth root of 16 is just 2. So this all just becomes that. By the way, what operation is in between the 2 and the fourth root of 3? What is it? Yeah, it's multiplication. So just keep that in mind. It's always multiplication. You're not adding them or something weird. Okay, so then without me even giving you an intro, do this for me. Okay, what's the largest perfect fifth that goes into 64? 32. And it goes in twice. The fifth root of 32 is 2. There is your answer. How did you do? So good? So good. Okay, so what I'm thinking is before we break for lunch, I'll have you practice with just numbers. And then when we get back, we're going to throw variables in. How about that? Oh, right.
I feel like even if we disagree, it's